So what if an AI could understand a picture, kind of like we do, by actually reasoning about what it's looking at, not just matching patterns? Well, we're about to look at a wild new method from Meta AI that basically teaches machines to do exactly that. It forces them not just to see, but to actually comprehend.
All right, let's just start with a little challenge. Take a look at this. It's like a digital jigsaw puzzle, right? Except someone's thrown out most of the pieces. Is it even possible for an AI to figure out what the original picture was from just these random scraps?
Well, check this out. The AI gets the messed up image on the left, and from that tiny amount of information, it reconstructs the image on the right. And it's not just guessing colors, it's understanding the idea of a flamingo, the curve of its neck, the way its feathers look. The big question is, how on earth does it do that?
And that how? Well, that's exactly what we're breaking down today. Because this isn't just some clever party trick, it's more like a game of imagination that fundamentally teaches the AI about our visual world.
See, this ability to fill in the blanks from such sparse information, it's a sign of something much, much deeper going on. This is a massive leap forward for what's called self-supervised learning in computer vision.
To really get why this is such a game changer, we first have to talk about a huge problem in AI. It's absolutely massive appetite for data.
For a long time, training powerful vision models meant using brute force. You'd need these gigantic data sets. I'm talking hundreds of millions of images. And the worst part, every single image had to be painstakingly labeled by a person. This is a cat. This is a car. You can imagine, this process is incredibly slow, it's super expensive, and honestly, it's been a major roadblock holding back progress.
So the solution is this really elegant idea called self-supervised learning. The core concept is just beautiful. Let the AI teach itself. Instead of waiting for human labels, the model learns the deep patterns and structures directly from the raw data. It basically creates its own puzzles, and then it solves them.
And that brings us to the secret sauce behind this whole thing. It's called the Masked Autoencoder, or MAE for short.
You know, the researchers who built it put it best themselves. The idea is just wonderfully simple. You take an image, you hide a big chunk of it, and then you ask the AI to fill in the blanks. The supervision, the answers to the test, are just the pixels you hid in the first place. But here's the part that's kinda nuts. They don't just hide a few pixels here and there. They hide a massive portion of the image, a staggering 75% on average. Now, to put that in perspective, similar techniques for language AI usually only mask about 15% of the words. This is way more extreme.
So, why go so extreme? Well, it's because images have a ton of redundant information. If you only hide a tiny patch, the AI can pretty much just cheat by looking at the pixels right next to it. But when you get rid of 75% of the image, there's no way to cheat. The AI is forced to develop a real, high-level understanding of the subject. What makes a dog look like a dog, or what a car actually is.
So here's the play-by-play. Step 1. The image gets broken up into a simple grid of patches. Step 2. Most of them, that's 75%, get randomly tossed out. Step 3. A really powerful part of the AI, called the encoder, looks at only the 25% of patches that are left. And finally, Step 4. A much more lightweight component, the decoder, takes that compact information and uses it to rebuild the entire image. Now, the real genius here is what they call an asymmetric design. See, in the old way of doing things, the whole heavy-duty AI model had to process 100% of the image data, which takes a lot of horsepower. With MAE, the super expensive encoder only has to deal with a quarter of the image. It's a huge, huge gain in efficiency.
And the real-world payoff for that efficiency? It's massive. This approach makes training these giant AI models more than 3 times faster, and it uses way less memory. And that doesn't just save time and money. It actually makes it possible for researchers to build even bigger and more powerful models than they could before.
Okay, so the theory is elegant, the efficiency is fantastic, but does it actually work? Let's take a look at the results.
Here you go. On the far left, that's the input the AI gets. Just a few random bits of a dog on a floor. In the middle is what the AI comes up with, and on the right is the original. I mean, the result is incredibly coherent and shockingly accurate.
And it gets better. Look at this cheetah. The AI wasn't just fed a bunch of cheetah spots. It was given some spots, some blurry background, maybe a piece of an eye, and from that, it reconstructed the entire face. This proves it's not just learning textures, it's learning the concept of cheetah.
Now this one is even more impressive to me. To reconstruct this clock, the AI has to do a kind of visual reasoning. It needs to understand the idea of a circle, the layout of numbers on a clock face, where the hand should be, all from a few random patches of stone and shadow.
And listen, it's not just cool pictures. The hard numbers totally back this up. When they tested it on the big industry benchmark, ImageNet, one of the beefiest AI vision models out there hit 87.8% accuracy after being pre-trained with MAE. That actually beat the old record holder, which had to be trained the old-fashioned, supervised way.
So here's the crucial takeaway. MAE doesn't just work, it really excels. Especially when you get to these huge, powerful AI models, this pre-training method helps them learn things that are more robust and flexible than just being spoon-fed perfectly labeled data.
Okay, so let's just zoom out for a second and think about what this really means for the future of artificial intelligence.
It all kind of boils down to 4 key things. 1, MAE is a crazy efficient new way to train AI. 2, it helps break our dependency on all that expensive human-labeled data. 3, it set a new record for accuracy. And 4, its efficiency opens the door to building even more powerful AI models in the future.
When you really think about it, this is all about changing how machines learn to see the world. I mean, we humans do this constantly, right? We make sense of everything from incomplete information, a quick glimpse of a car in traffic, hearing a fragment of a conversation. This is a huge step toward teaching machines that same fundamental skill.
And that really leaves us with one final pretty fascinating question. When an AI can reconstruct a whole scene this well from so little information, has it just learned to see what's there? Or is it actually taking the first steps toward learning how to imagine what isn't?